Hello, this is Mr. Pedraza, and we're here talking about greatest common factor. We're going to start the lesson by just talking about what it means to be a factor. This first question says, what are the factors of 27? And we're just listing the numbers that go into 27. There's 1, 3, 9, and 27. So those would be the factors of 27. GCF stands for greatest common factor. And when you have a pair of numbers like 9 and 27, what we're asking for is the biggest number that you can divide both numbers by. So you can divide 9 by 1, 3, and 9. You could divide 27 by 1, 3, 9, and 27. So 9 is the biggest number that goes into both. For 12 and 15, you think about numbers that go into 12. You got 3, 4, 6, 12, and then 15, 1, 3, 5, and 15. And 3 is the biggest number that goes into both of those. 7 is a little more challenging. If you're trying to think about numbers that go into 27 or 72 and 48, you might think about numbers like 2 because they're both even. 4 works. And you can get out a calculator and start dividing. And it might appear that it might be a number like 8 or 12, but it ends up being 24. 24 goes into both of those numbers. It goes into 72 3 times, and it goes into 48 2 times. On number 8, we have some variables. So you look at the two numbers. You got 2 and 4, and the biggest number that goes into 2 and 4 is 2. And if you have variables like this, what you're asking yourself is, how many x's can I take from both? The first one has 2 x's, and the second one has 4 x's. So you can take up to 2 from both. You can't take 3 from the first one because it doesn't have 3. From the second one, you could take 1, 2, 3, or 4, and so the common factor would be 2 for both. If they both have an x, it's the lower of the two numbers. Let's take a look at number 9. For the numbers 16 and 24, 2 goes into both, 4 goes into both, but 8 is the biggest number. The first one has 2 x's, the second one, 2 a's. The second one has no a's. So what do they have in common? Well, they have no a's in common, so I'm not going to put any a's. The first one has 2 b's, the second one has only 1, so they have 1 in common. The first one has 3 c's, the second one has 2 c's, so in common they have 2 c's. You could say it's the smaller of the two exponents, right? For the c's, between 3 and 2, 2 is the smaller number. For the b's, between 2 and 1, 1 is the smaller number. And then between 2 a's and no a's is the smaller number. So if I was looking at number 10, I'd find the biggest number goes into 2, 4, and 12, and that's 4. This one has 2 x's, this one has 1 x, and this one has 3 x's. So the common factor there would be 1 x. They have at least 1 each. Okay, so now we're going to get into doing the greatest common factor of a polynomial. The definition of factor is writing an expression as the product of 2 or more expressions. It's taking a term and separating it into 2 terms that multiply to that term. We're going to be doing essentially the opposite of distributive property here. So I'm going to look at these and say, what is the GCF of 2 and 8? And that's 2. This has 2 x's, this has 1, so they each have at least 1 x in common. And I'm going to put parentheses here. And what I want is I want to figure out what would distribute to go back to that original problem. You can pause for a second and think about what would distribute to go back to 2x squared plus 8x. So I know when I multiply 2x times this first term, I'm going to need this 2x squared. Well, I already have a 2 in there and an x, so I need 1 more x. 2x times x is 2x squared. Now I gotta say, what do I need for an 8x? Well, 2 times 4 is 8. And when I distribute that 2x, that x goes with it, and it will give me that other x I need. So the 2 times the 4 is 8, and then the x would be 8x. That's my answer. The inverse operation of factoring is called multiplication. In these problems, it's specifically distributive property. So how do you check a factoring problem? You just multiply. In all of these problems, you can check by doing distributive property. Okay, so on number 13, I'm just going to do distributive property. It asks me to multiply 3x times x minus 5. So I'm going to distribute here, get 3x squared. I'm going to distribute here and get negative 15x. Now the next problem is the opposite. It asks me to factor. So I'm going to look at the numbers between 3 and 15. The GCF number is 3. This one has 2 x's. This one has 1 x. So they both have at least 1 in common. Then I'll put parentheses. And I'm literally going to divide here. I'm going to say, what is 3x squared divided by 3x? And 3 divided by 3 is 1. And x squared divided by x would be taking an x away, and I get x. I can do the same thing here. Divide by 3x. 15 divided by 3 is 5. And these x's just cancel. Just taking an x away, and I end up with 3x times parentheses x minus 5. And if you look at these two problems now, you can see that they were just opposites of each other. The answer to this one is this answer, and the answer to this one is this one's question. Okay, moving on. So now we just have a lot of example problems, and feel free to pause and try these on your own if you'd like, and we're just going to go ahead and get going. So I'm looking for the GCF. Between those two numbers, 4 is the greatest common factor. They each have an x, so I put down an x. And then I said we're going to divide here. Whether you actually write this out or not is up to you, but I'm dividing 12 by 4, that's 3. When I divide these, I subtract the exponents. I just say there's 2, and I'm taking 1 away, so 1's left. Then we divide 16 by 4, and that's 4. Take an x away, and there's no x. When you want to check this, you can do distributive property. If it distributes back to the original, then you did it correctly. Okay. This problem, 4 comes out of each of these. They each have an x. I'm dividing by 4x. So 8 divided by 4 is 2. Take an x away, and you have 1x left. When you go over here, you need to make sure that you put something. You can't put 0. That wouldn't make any sense. That wouldn't distribute back to this. So you got to think about what is 4 divided by 4. Well, that's 1. Take an x away. There's no x. There's your answer. On this problem, the GCF is 3, and we don't take out any x's because this term doesn't have an x. So you just divide by 3, divide by 3. You get 2x plus 1. Done. Same thing on this problem. 6 comes out of each of these. The first term has an x, the second one doesn't, so I don't take out any x's. I divide these both by 6. I get 3x plus 4. Done. On 19, there is no number to use the GCF. You never use the number 1. So I'm not going to use a number, but they each have x's. Now, this one has 3 x's, and this second one has 2 x's. So the GCF here would not be x, it would be x squared. They each have at least 2 x's. When I go to take those away, I'm taking 2 x's away from each. So that one had 3, take 2 and you got 1. The 2 just stays there. And then 2 x's take away 2 is no x's. And that's your answer. Okay, let's do 20 the same way. I'm going to figure out what number I could take out of 8 and 4. 2 works, but the greatest common factor is 4. This one has 4 m's, this one has 2. The most they have in common is 2. When they both have variables, it's the smaller of the two, right? Between 4 and 2, 2 is a smaller number. And then we divide by 4 and take 2 m's away. 8 divided by 4 is 2. Take 2 m's away and you have 2. 4 divided by 4 is 1. Take 2 m's away and you have none. So this is just a 1. And then again, you can do distributive property to check these. 21 is different because it has 3 terms. That's not really a big deal. I look at these 3 terms. All of these are divided by 3, divisible by 3. So my GCF is going to have a 3. This has 3 m's. This one has 2 m's. And this one has 1 m. So in common, they have 1 m. And I'm going to divide everything by 3 and take an m away from each. So 3 divided by 3 is 1. Take an m away, and now this one only has 2 m's. I don't need to write that 1. 9 divided by 3 is 3. Take an m away, you only have 1. 18 divided by 3 is 6. Take an m away, and this has no m's. Done. This problem, I look at the numbers. 2 comes out of each, so I put down 2. This one has 2 x's, this one has 1 x, and this one has none. So no x's come out of this. Remember, it's always the smallest of them. So between 2, 1, and none, none is the smallest. And then I'm just going to divide all these by 2. Divide by 2, divide by 2, divide by 2. 2 divided by 2 at the end here is 1. Again, you could check by using distributive property. 23 says, determine which expression is equivalent to 4x squared plus 4x. So I do my GCF. 4 and x are the GCF. Divide by 4 and take an x away. I get x plus 1. And I can see over here the answer is B. I could have done distributive property on all 4 of these, but I could also do GCF. So that's 2 different ways you could do that. And that's all. So hope you enjoyed that lesson, and go ahead and do